All right, we are on page 369. So yesterday we were looking at how we can solve oblique triangles, okay, non-right triangles, and how we can utilize trig to help us do that. We first kind of derived or developed the law of sines, where we have the sine of an angle over its opposite side. If we were to do that division for every single pair of angle and side in a triangle, they would all end up being the same. That's why we were able to set all those fractions or ratios equal to each other. We left off yesterday, I think, just writing down the law of cosines. Is that right? We didn't do any of the examples just yet? Okay. So the law of sines only works if you know an angle and its opposite side. Okay, we might not always have that information available to us. That's why we're going to discuss today the law of cosines. So they look a little bit more complicated than the law of sines, but I'm hoping that we can kind of see a pattern within those equations. If you know one of them, you know all of them, okay, if you can recognize that pattern. So we're going to practice these today with these two examples. All right. So the first one, we'll go ahead and draw a triangle just as a reference. Angles ABC. And notice how we're given all three side lengths. So side A is 6. That would be opposite angle A. Side B is 4 and side C is 9. So this is actually a perfect example where the law of sines could not be used, because notice how we don't know an angle. Okay, we have all three sides. So let's try to just pick an angle, either A, B, or C. Which one do you want to try to solve for first? I mean, we'll find all three eventually, but we've got to start with one of them. Do we have a preference? You just want to do A? We'll start there. Okay, so let's take a look at the law of cosines. Angle A, meaning the capital A, is found within that first law of cosines. So we'll go ahead and utilize this first one, fill in all the information we know, and somehow we should be able to figure out that angle A. So if we're trying to figure out angle A, that means we have to start with side A, which would be 6. The other two sides we did not choose were the 9 and the 4. Okay, order doesn't matter. You can write the 4 and then the 9 because you're adding. Minus 2 times 9 times 4. And then after that, we got to multiply by the cosine of A. So we were to fill in every single side length, which means we should eventually be able to figure out the angle in the end. So this is when it's going to be kind of calculator work from here. We can do 6 squared, which would be 36. And then we can do 9 squared plus 4 squared. That would be 97. Let's see, 2 times 9 times 4 would be a 72. And that's being multiplied by cosine of A. All right, so where do you want to go from there to kind of get the A all by itself? Go, Rebecca. Okay, there we go. We'll subtract the 97 over. All right, so 36 minus 97 gives us a negative 61. Next. Good, Ashlyn? There we go. Divide negative 72, so we'll get 0.8472. And then how do we move a cosine over?
Would you use cosine to the negative first?
Cosine to the negative first. Good. So on our calculator, okay, the cosine negative first button is right above the cosine, but you have to hit the blue button first. And we'll type in 0.8472. So our angle A is 30.1. Maybe we'll round. Make sure you're in degree mode. Okay, if you did not get that answer, you're probably in radian mode. Okay, make sure you're in degree mode. So we'll say A is 32.1 degrees. We actually might get to radians today. We'll talk about what those are. All right, so maybe we'll label that in our triangle, 32.1 degrees. So we figured out one angle. We have two more to do. Which one do you want to figure out next? You want to do B or C? We don't have a preference? Good, Marie? We'll do B. Okay, now take a look at this. I think I've been saying a lot the last few days. The more information you know about a triangle, okay, the more options you start to have. And that's when it can start to get to be a little bit, not necessarily confusing, but difficult for us to make a decision as to which way we want to go about solving another triangle. If you want to figure out angle B, we can do the exact same thing we just did with the law of cosines. Okay, just with angle B instead of angle A. But now notice what we have. Do we know an angle and its opposite side? Don't we know what angle A is and side A? Okay, so we could possibly use law of cosines. We have that relationship showing up in our triangle now. So do we want to repeat the law of cosines that we just did, or do we want to use law of sines? We have options. Do we have a preference? Do you want to practice law of cosines again? Let's try that. Okay. But you could use law of sines. It would work out the same way. So let's see. Angle B, if you need to, go ahead and reference the middle equation in that box. But maybe we can think about it, okay, without looking at the top. Let's see if we can go ahead and write the law of cosines. If we're trying to figure out angle B, that means we have to start with side B. So that would be 4. The other two sides we didn't use were 9 and 6. We then subtract 2 times 9 and 6. And on the end we have cosine of B. From here, it's going to be some calculator work. So 4 squared, we got 16. 9 squared plus 6 squared, we'll have 117. 2 times 9 times 6, 108. And then cosine B on the end. All right, so just like the previous one, we'll start to move some things to the other side. We can subtract the 117 over. Get negative 101. One of my favorite movies. Those dogs were so cute. 101. We can divide negative 108. 0.935. And move the cosine over by using the inverse. We get 20.7 degrees. We're doing okay? Can we figure out the last angle, angle C? We can use law of cosines, we can use law of sines, or maybe there's a quicker way to get it? Yeah?
The two angles that we had and subtract it from 180.
There we go. So we know there's 180 total. We can subtract the two that we already know to figure out kind of the missing one. So let's see. 127.2. I like it. All right. We're not quite done with this triangle just yet. Even though we know every single angle and every single side, I want us to practice finding the area like we discussed yesterday. I know it's not a part of the directions, but I'm going to throw it in there just so we can get some extra practice. Okay. Do we remember the criteria to help us find the area of an oblique triangle? What do you think, Rebecca? It's always going to be 1/2 base times height, okay, but for an oblique triangle, there's a little bit more to it. We used that formula yesterday to help us get this new one for us to use. So it's a variation of 1/2 base times height, yeah.
Do you use like the two sides and the
Yep, we need a side angle side relationship. Okay, so we're going to look for two sides and the angle that they form. Now, we know every single angle and every single side in this triangle, so again, we have options. You need to pick two sides. Which two sides do you want to use? It doesn't matter. Yeah?
C and B.
C and B, you said? Okay, so that would be side 4 and side 9. Okay, so it's a variation of 1/2 base times height. We're going to have that 1/2 out front, and then we're going to multiply the side angle side relationship. So if you choose side 9 and side 4, what is the angle that those two sides form? Can we see it? Yeah? 32.1, that angle A, right. So then we're going to have sine of that 32.1 on the end. So it still is 1/2 base times height, but it's a variation of that because this is not a right triangle. So from there, like the other ones, it's just some calculator work. We'll go ahead and check out the area. Bless you.
Thank you.
I think we'll get like 9.6 something if we round. All right, let's try another example. We'll go on to part B here. Let's draw a triangle just for a visual. Angles ABC. Side A is 12. Side C is 7. Angle B rather is 65. Do we have enough information to figure out the area? Do we know a side angle side relationship? Maybe we'll start there. Okay, let's do area. We need 1/2. The two sides we know are 7 and 12. And the angle they form is 65. So we need sine of 65. $38.1. Sound good? All right. Let's go ahead and try to figure out the other missing pieces. So the other side length we don't know, and then the two other angles we don't know. What piece do you want to try to find first? Do we want to try to find side B or an angle? Think about, okay, let's ask ourselves this. Do we know an angle and its opposite side? No. We know an angle, but we do not know its opposite side. So law of sines is a no-go. At least just now, it's a no-go. So we have to use the law of cosines somehow. And if you take a look at the law of cosines at the top, we somehow should know perhaps every single side length to help us figure out an angle. Do we know every single side length just yet? No. So we probably cannot figure out an angle because we don't know all the sides. That means we have to figure out the side first, and then we could possibly go about figuring out the angles. Can we set up an equation using the law of sines? Do you see it? Yeah.
Could we use the b squared and then plug in our value for big B into cosine and solve for b squared?
There you go. Notice how we know angle B, so we can fill in that big B spot. And we know sides A and C, so that means we should be able to figure out what little b is. Okay, so it's kind of we're still using law of cosines, but just not in the same capacity as the previous example. Okay, in the previous example, we knew all the sides and figured out an angle. Now we know an angle and we're figuring out a side. So we're kind of going backwards. Let's try that. So b squared would be 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 65. So from here, it's going to be some calculator work. What's nice about this setup is notice how on the right-hand side of your equation, everything is a number. So you can type in that entire side on your calculator and just hit enter and get a number. Let's go ahead and try it. Okay. So we have 7 squared plus 12 squared minus 2 times 7 times 12, and then cosine of 65. So that entire right side we'll say is 122. And lastly, to get B all by itself, we'll just square root it. I'll say 11.05. Now, hopefully we realize that since we're square rooting both sides, we would need a plus or minus in there. But the minus probably doesn't make sense because we're talking about a length, right? The side length of a triangle. So the negative might not be necessary. We'll just go ahead and leave it as the positive version. Okay, so we have 11.05. Maybe we'll go ahead and write that in. We still got to figure out 2 more angles. So let's ask ourselves, do we want to figure out angle A or angle C? You want to do angle A? Okay. And then you got to figure out, how do you want to figure out angle A? Do we know an angle and its opposite side? We have angle 65, bless you, and its opposite side was 11.05. So we could use law of sines, but now notice how we know all 3 sides, so we could probably use the law of cosines. You have options. What do we want to try? You want to try law of sines as a refresher from yesterday? Let's try that. Okay, so law of sines, we need the sine of the angle we know, which would be 65, and we'll divide that by its opposite side, which we just found out was 11.05. If we're going to try to figure out angle A, we'll go ahead and write sine of A, but we have to divide that by side A, which would be 12, the side opposite angle A. Okay, we're setting up a proportion or a ratio. So let's see, on the left-hand side, we can type that in. Sine of 65 divided by 11.05, 0.082. Can multiply the 12 over. We have 0.9842. And then move the sign over using an inverse. Looks like angle A is 79.8 degrees. If you would have used law of cosines, you still would have got the same result. Okay, you have options. Sometimes that's the tricky part. Okay, which method do you want to use? So angle C should be really easy for us because now that we know two angles, we could just subtract them from 180 to figure out the missing one. So it looks like we get 35.2. Bless you. You doing okay? Perfect. All right, we're going to briefly start the next section today. It's still relating to trig, but in this section we're going to focus a lot on vocabulary or terminology because the deeper we get into these trig functions and their relationships to each other, we need to be able to use correct words and phrases when we're discussing these. So I want to make sure that we're okay with the vocabulary and the terminology before we get too deep, okay, into these trig functions. So take a look on page 375. Okay. We're going to practice drawing some angles. And how we do this is pretty particular. We're going to draw an angle the same way every single time. It just depends on how big that angle is. So as I draw, I'm going to draw the first one, but I want you to pay attention on how I draw it. And then we'll talk about kind of the terminology or the vocabulary for these angles that we draw. So when you draw an angle, at least in terms of a coordinate plane, you see how we have like a graph there, an x and a y axis. We always start on what's called the initial side. It's an arrow or a ray that starts on the positive x-axis. So we're going to go ahead and label this the initial side. Initial meaning your starting side. If I want to draw a 215 degree angle, how about we think about this? How many angles are in a circle? There's 180 in a triangle. Do we know how many are in a circle? 360. Okay. So if I were to label this, if I were to do a whole circle, okay, I'm starting with an angle of 0. That's my initial side. If I go completely perpendicular, that would be 90. If I do a half of a circle, that would be 180. If I do 3/4 of a circle, that's 270. And if I do a full circle back to where I start, that's 360 again. So the initial side could either have a 0 degree angle, because that's where you start, or a 360 degree angle if you go all the way around. Where do you think 215 would land?
Excuse the interruption. At this time, all students going on the zoo filter with Mr. Craig should report to the front entrance. The students going with Mr. Craig to the zoo to the front entrance. Thank you.
Based off of how we labeled those different axes, where would 215 degrees land? Can you describe it? What do you think, Rebecca?
Probably about halfway between 180 and 270.
Somewhere in here, right? Okay, so if I were to draw a 215 degree angle, I'm going to start my pen on that initial side, and I'm going to loop it around however far I think that 215 degrees is. So Rebecca said somewhere kind of in quadrant 3, between 180 and 270. Whenever you stop your pen, we're going to create another ray from the origin that kind of touches that arc or angle that you drew. This other ray that you draw is called the terminal side, because that's where you terminate, aka end, your angle measurement. Are we okay with the vocabulary so far? Initial side is where you start, terminal side is where you end. Okay? This arc that you draw is your angle of rotation. Let's see if we can figure this out. If this x-axis has a 180 degree measurement, because you would do a half of a circle, how far are you away from this 180 if you ended at 215? What is this little angle in there? Can we figure that out? How far away is 180 from 215? Did you get it, Emily? Yeah. 35 degrees. Good. That 35 is called a reference angle. Okay, we're going to write all these vocabulary terms down with definitions in a second, but I just want to make sure that we label everything because we have a lot going on. The initial side is where you start your angle. Terminal side is where you end it. Okay, that angle you draw is the angle of rotation, and we should be able to figure out a reference angle. How far our angle we drew is away from the x-axis. Essentially, that would be the 35-degree reference angle. Okay, so that's an angle of 215 that we drew. Let's try 575. Now, if you notice how we labeled these, if you do a full circle, you only go 360 degrees, all right? How much further do we have to go to get to 575? Yeah? 215. All right, so check this out. We're going to start on the initial side. In order to draw a 575-degree rotation, we have to do one full circle, okay, 360 degrees, but then an additional 215. When you end your angle, we're going to go ahead and draw the terminal side. What's our reference angle for this one? How far are we away from that x-axis? Can you visually see it, perhaps? Wouldn't that be another 35 degrees? Do you see how both of these angles terminate, aka end, in the same spot? You see how they have the same angle of termination, perhaps? Right? That means that we're going to have the same reference angle. Even though we traveled more of a rotation, 575 degrees, we're still landing in the same spot. Okay? It happens to be that same terminal side. What if we wanted to draw a negative angle? Okay, let's start with our initial side. Did you notice how we drew the previous two ones? Did you notice how they were counterclockwise? Okay, we went from the first quadrant to the second quadrant down to the third. If we have a negative angle, we're going to go ahead and travel backwards. So instead of going counterclockwise, we'll go clockwise. Now if we're going clockwise, 145 degrees is not quite 180, so we're not going to make a full half a circle. We might be somewhere right there. So we'll draw the terminal side. Can we figure out that reference angle? How far are we from the closest x-axis? In other words, how many more degrees do we have to travel to get to that half circle, that 180 degrees? Yeah, 35. Okay, so they are three completely different angles, okay, because we have different angles of rotation, but notice how some things are the same. We have the same initial side, we have the same terminal side, and we have the same reference angle. They're three different angles, but they do have some similarities in common. Okay, so we're going to go ahead and write down some of those relationships that we might notice. Okay, what do these have in common? They have the same initial and terminal sides and they also have the same reference angle. Okay, now we'll go ahead and write down the definition of a reference angle just so we have it in our notes. A reference angle is the acute angle. Do we know what acute means? It doesn't mean a very pretty angle. Acute angle? Yeah? Less than 90 degrees. Good. Okay, a reference angle is always less than 90 degrees. The acute angle made from the terminal side and the closest x-axis. All right. Some differences, though, is how far we rotated. Notice how in this first one we went 215 degrees. The middle one, we did a full rotation and then some more. Okay, we did more than a full circle. And this last one, we kind of traveled backwards. So even though we do have these similarities, there are a few differences. So a difference might be the angle of rotation and the direction of the angle. Okay, if it's a positive angle, we go counterclockwise. If it's a negative angle, we're going clockwise, aka down from that initial side. We doing okay so far with the words? Okay. So let's go ahead and we're going to go ahead and define again these terms: initial side, terminal side, reference angle, and angle of rotation. Okay, so the initial side always starts on the positive x-axis. The terminal side is the ray where the angle ends. Remember, a ray from geometry has an endpoint and an arrow. So the endpoint is at the origin and the arrow goes out from there. The reference angle we defined above, so maybe we'll say C above for that definition. And the angle of rotation is, we'll perhaps say, the arc used to show the angle path. Sometimes it can be a little arc, sometimes it can be a big arc. Like if you look at the middle example, it kind of looked like a snail because we had so many, or we had a lot of rotation. So it just depends on the type of angle that you have. Okay. Last but not least, one more term here to go over. All of these angles are called coterminal angles. What do you think that word coterminal might mean? Think about the word itself. Co might mean something, terminal means something. Can we define that term? Terminal means to terminate, yeah?
All the angles share the same end.
They share the same end. They all land in the same spot. Even though you might do different arrows of rotation or angles of rotation, you're still landing in the same spot. So we'll say angles that end in the same spot. Okay, AKA they have the same reference angle, but different angles of rotation. All right. I'm glad we got those terms down. Okay, we'll come back to those on Monday. We'll just review what they mean, and then we're going to take a look at how we can manipulate and describe angles now that we have these ways or these terms to use. Have a good weekend, guys.